Okay, here is an example of the extreme value theorem being used. Remember, we need to make sure that we're dealing with, or the conditions, I should say, are satisfied for the extreme value theorem to be applied, and they are because we do have a continuous function and differentiable on the closed interval from -2 to 2, okay, since we have a polynomial function here. So, what we need to do is to apply the extreme value theorem, and I know I used this in the last video if you took a look at that, and slide this over a little bit. And so, here's not using calculus. We just graph the function and just examine it from -2 to 0. So we kind of ignore this part of the graph and this part of the graph here because they're to the right at 0 and to the left at -2. And we see the high point here is at the value of 24.815. Notice that's this purple point actually is corresponding with this point right here. And here's the 0, 10. And essentially what we're doing here is, we're saying that we're guaranteed an absolute max and an absolute min. And if they occur, the extreme value theorem says they occur either at a critical number in the interval or it occurs at one of the or at the two endpoints, depending on the situation. So using calculus over here, I'm going to go ahead and take the derivative and simple polynomial here is its derivative. We find the critical numbers by setting the derivative equal to 0. This one here happens to be a quadratic that we can factor. You can see my erase marks there for my trial and error method. But it factors down to 3x plus 5 and x minus 3. You could have also used the quadratic formula as well. Bottom line is we get -5/3 and 3. Notice we do get a critical value here, 3 outside. You got to be careful. Make sure these fall within the given closed interval. So 3 wouldn't even be considered here because, again, it's not in this closed interval. So the 3 points that we're going to test, we test them below, -5/3, -2, and 0. And the highest value of those threes are going to be the 3 points are going to be the absolute max, and the absolute, the least of the three here, in this case 10, is going to be the absolute min. Okay. So again, just a matter of semantics here. Remember that if they're asking for the values, you need to type in the values of the functions. Okay, so this would be the 24.8. Okay, and depending on how many decimal places you would have to round also. The other thing that we would do is we would, if you're asked where they occur or where these points occur, well, then those are the x values. So in other words, the max of 24.8 occurs at x equal -5/3, and the absolute min of 10 occurs when x is equal to 0. Okay, so there you have it. Just a quick example there using the extreme value theorem with a relatively simple polynomial function. All right, we'll see you next video.